All right. The fifth question is that if the strength of metal plates is normally distributed with this normal distribution, right? This is normal distribution here. What is probability that the strength of randomly selected plate is within 1.5 standard deviation of its mean? Random standard deviation of its mean, right? We know this is normal distribution. We know this is normal distribution. And the normal distribution here is basically n mu sigma square. That's it, right? N mu sigma square. Now, what we are trying to find is that what is the probability that the strength of a random selected plate is within 1.5 standard deviation of its mean. So we are trying to find n x, which is bigger or equal to the lower side of the 1.5 standard deviation, right? So the mean is mu. The standard deviation is sigma, right? So mu minus 1.5 sigma. This is smaller or equal to mu, the positive side of 1.5 standard deviation, right? So mu plus 1.5 sigma. That's the positive side of it. And that gives us, that's basically the probability we're trying to find, right? This is the probability we're trying to find. Now this, obviously we are missing quite a few important values here. We don't know mu, we don't know sigma, but also this standard deviation, this is normal distribution, but not a standard normal distribution, right? We mentioned that if we want to calculate something, we want to use a table provided from the book, we have to convert this to a standard normal distribution. For a standard normal distribution, really what you do is that you use whatever this value is, well, whatever the x is, you want to convert it to y, right? And then what you need to do with x is x minus mu divided by sigma. You use whatever that value is minus the mean value divided by sigma. Of course, if you do that to the random variable, it needs to be applied to the left and to the right as well. So this equals to mu minus 1.5 sigma minus mu divided by sigma, right? So that's this side. And on this side, it will be mu plus 1.5 sigma minus mu divided by sigma. That's the result. That's that, right? And you see that we have mu here, we have sigma here on top, sigma in the bottom. Actually, they are all removed, right? So this actually become, remember when we do this convert, this becomes z, right? Z bigger or equal to negative 1.5 because this and this removed, this and this removed, this is 0.15, that's where we get that, right? Same thing here, this and this removed, this and this canceled each other, we got smaller and equal to 1.5. That's how we find that result, right? So now this basically become this, right? It's in a certain interval, so we use the top interval minus this one, minus the lower interval, right? Of course, I mean, if you are still a little bit confused, this obviously equals to phi z smaller or equal to 1.5 minus phi z smaller or equal to negative 1.5. Right? So that's how we, from here, this equals to this equals to this. 1.5. So that's how we get this, right? Then we can go to our table, and then you can easily find out 0.933 minus 0.067. This is this value, this is this value, and use that we can get 0.866. This is our final result, which you can actually can already see that under this big black bar here, this part, but I pretend it's not here to just show you how we calculate this, right? And by the way, you can find this note on our Microsoft Teams classroom as well, under our week 10 quiz 2 practice. Okay, that's that part. And then the question 6, right? Question 6. So here's the question, what it's about. It says, the duration of the construction of a single family house can be modeled as a normal distribution. The average time to build is 90 days. Furthermore, 80% of the projects are completed within 105 days. What is the standard deviation of the distribution? What is the standard deviation of the distribution? Again, I showed the calculation, but I use black bar to cover it, and then just to pretend it's not there, I'm going to show you step by step how do we get there, right? So the probability is that we know 80% of the projects completed within 105 days. We also know that average time to build is 90 days. We also know that the duration, the distribution of the duration follows a normal distribution, right? This follows a normal distribution. If it follows a normal distribution, then we know, well, we'll talk about the normal distribution part later, right? But first, we know that 80% of project finish within 105 days. So that basically tells me x smaller or equal to 105 equals to 0.8. That's what we know. That's what we know, right? We also know that this number, this x follows normal distribution. We know it's normal distribution, but it's not a standard normal distribution, right? We want to convert it to a standard normal distribution. To convert that, what we need to do is that phi x minus mu divided by sigma. And of course, if we do that for the left part, obviously we need to do that to the right part as well, right? So this is smaller or equal to 105 minus mu divided by sigma. Right? So that's still equal to 0.8. Nothing changes, right? And in this equation, this become a phi, right? This become phi. We convert this is z, so we can ignore that part. We can omit that part. So basically, what we have is for phi 105 minus 90 and divided by sigma. That gives us 0.8. That gives us 0.8. So we know we don't know the standard deviation. That's what we are trying to find out, right? But we know everything else. We know everything else. We can go to the table, try to find 0.8, and then if the probability equals to 0.8, what is this value? What is this value? So if you go to the table, you can find out roughly 105 minus 90 divided by 5, sigma equals to 0.84. Again, how do I get from here to here? You need to go to the book, find the table, and then find out when the probability equals 0.8, what is this value? What is this value? So I get that, then based on this, I can find out sigma equals to 17.86, something like that. So that's how we calculate question 6. So again, you can see already that, right, the normal distribution is a big part of this exam. And make sure you understand that correctly, and then I'm sure there are multiple questions about normal distribution going to be there in quiz 2.